MCP Explained, Playlist 2, Episode 2, One Protocol, Any Agent, Any Tool. Last episode we saw that the model only produces text. The orchestrator is the part that executes tools. So here's the next question. How does the orchestrator know what tools exist, and how does it actually talk to them? That's what MCP answers. Before MCP, every AI editor had to write its own integration for every tool. Cursor and GitHub, custom code. VS Code and GitHub, different custom code. Claude Code and Postgres, yet more custom code. 3 editors, 3 tools, 9 separate integrations. Add a new tool and every editor has to update. Add a new editor and every tool has to be reintegrated. N times M custom code, it did not scale. Part 1, the 3 roles host, client, server. MCP replaces all of that with 3 clearly defined roles. First, the host. The host is your AI application itself, your editor. Cursor, VS Code, Claude Code, these are MCP hosts. Second, the client. The client is a small connector that lives inside the host. The host is not the client. The host contains clients, 1 client per server. Third, the server, a separate program that exposes capabilities. Say it again. Host contains clients. Each client connects to exactly 1 server. If your editor uses 5 MCP servers, it has 5 clients inside it. That 1-to-1 pairing is what keeps the system clean. Here's the part most explanations skip. An MCP server doesn't just expose tools, it exposes 3 things. Tools, functions the model can call, like create a GitHub issue. Resources, read-only data sources, like the contents of a file or a database table. And prompts, pre-built templates the user can pick from. Tools are model-controlled, resources are app-controlled, prompts are user-controlled. Part 2, the protocol in action. Initialize, discover, invoke, execute. Watch what happens when your editor starts up. Step 1. The host creates a client for each configured server. The client and server exchange a handshake, protocol versions, capabilities. Step 2. The client asks the server, "What do you offer?" The server responds with its full list of tools, resources, and prompts. The host hands those tools to the language model as JSON schemas, the same schemas we saw in Episode 1. Step 3. The model decides it needs a tool and emits a structured tool call. The client forwards it to the right server. Step 4. The server actually runs the logic, queries the database, hits the GitHub API, reads a file, whatever the tool really does. Step 5. The result flows back through the client to the model, and the loop continues. One last piece. The transport. All of this travels over json-rpc, but it can run 2 ways. Local servers run as a child process on your machine and talk over standard input and output. STDIO transport. Remote servers run on a different machine and talk over HTTP. Either way, the protocol is the same. The model doesn't know which one it's using. Here's the payoff. Before MCP, N editors times M tools, custom code everywhere, nothing portable. After MCP, every editor speaks the same protocol, every tool speaks the same protocol, they all just plug in. Build 1 MCP server for your company's database. Every MCP-aware editor can use it. Build a new MCP-aware editor. Every existing server works on day 1. 1 protocol replaces N times M integrations. That is the whole point. Remember, host, client, server. The host is your editor. Clients live inside it, 1 per server. Servers expose tools, resources, and prompts over json-rpc. And the orchestrator from Episode 1, that's the host. MCP is how the orchestrator talks to the outside world. Host, client, server, 1 protocol anywhere. Next episode, the agent loop. Propose, review, apply, repeat. Subscribe, we crack open every bone.